In this video, we're going to use 3D scanning and Fusion 360 to solve a problem, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to use some 3D scanning and we're going to use Fusion 360 to design this part. Now, this part is going to be somewhat of a universal thing. Now, what I mean by that is oftentimes I get questions about 3D modeling or scanning certain things, designing certain parts, but oftentimes it really comes down to what you need to do with the tools. And what we're talking about is solving a problem. Now, problem is loosely defined here, but essentially what we're talking about is an earbud, in this case a Raycon earbud charging case, and the short USB cable. Now these things are designed essentially to plug into the side of a laptop and sit on a desk while they're charging, or to be in a drawer with a USB plug. Now what I found is that in most cases this thing is either hanging down off of a desktop computer if it's charging off the front of that, because the USB ports are quite a bit higher, or if you have it plugged into a wall plug, then you either need to try to balance this thing here or, again, just kind of leave it hanging. Those aren't really great solutions. A couple of ways that you can get around this is to use a longer cable. Then you have this thing sort of sitting somewhere that's far away from the plug or dangling down or sitting on the floor. But what I thought of is using this technology, in this case a 3D scanner and Fusion 360, to design a part that goes on the plug, and it gives us a little shelf. So this way it can kind of stay self-contained, plugged into the wall, and we don't really have to worry about it hanging, putting too much strain on the cables, or really having any problem with it just being in the way. Now, obviously, if you use a laptop to charge these things, not a big deal, but if you do use a wall plug, then it can be quite a pain. Now, this specific wall plug, this is a Samsung one. It doesn't come with the Raycons, but these have been in this shape and around for quite a while. Even these, the higher speed or higher amperage output ones, I mean, probably the last 10, 15 years, the outside shape of this hasn't changed. So if you have a Samsung or this plug, then the scan will be of this, so you can design whatever you want around it. But we're going to talk about the process. I probably throw up a little bit of information about scanning, or at least I'll put some links to other scanning videos. So I do have a video on how to use Einscan. We also did a short series on reverse engineering, which covered the scanning part as well as the reverse engineering part. So that's not what we're doing here. What we're doing here is we're going to look at using that scan data to build a part that fits this and has all of the details or features that we need to hold the earbud case. So a couple of things that we need to consider here. If you're following along, you can obviously go to the description of the video and download the data set and follow along. If you don't have a Samsung plug and a Raycon earbud case, then obviously it's not super helpful, but it's still something to play around with. I'll talk about the scan, some problems with the scan, some things to look out for, and we'll also talk about the process. There's a couple different ways that you can do this. In this video specifically, we're going to be using forms, because I think it's a little bit easier than doing sketches and mesh section sketches. We have a lot more flexibility on creating the shelf on top. And the end goal is to 3D print this, and I'd like to print without supports whenever possible. So this was printed in this orientation, and that's why these cutouts for the USB go all the way through, so I don't have a little roof there that we need supports or we need to have an arc to build back up to. And it fits pretty well. This one's a little bit small, so we'll talk about that. These things all come down to accuracy of the 3D printer, accuracy of the scan, which should be fine, and accuracy of our design. So with all that said, let's go ahead and hop into Fusion 360 and let's talk about the process. So in Fusion, the first thing that we have here is this is the version that I just showed you. Now, this one is not in the description. We're going to walk through the process of building something very similar to it. This design has two mesh bodies. It has the plug, and again, that was the Samsung plug, and it has the Raycon charging case for the earbuds. Now, the Raycon charging case, I didn't need the whole thing. I really only needed the bottom shape and the location of the USB plug. And the middle of these things have sort of a shiny plastic band that doesn't scan, and I certainly did not want to spray or prep this at all. And I didn't need that. So all I really worried about was scanning the bottom, I scanned the top, and then I let Xscan make it watertight. So with that in mind, that's why the scan looks the way it does. It's because that middle section was shiny and we really didn't need it. The plug scanned pretty well, even though I didn't prep anything. I did make it watertight, which ended up causing some problems. So for example, at the front, it wasn't able to capture the detail of this lip here. And obviously it wasn't able to capture the shiny metal for where it actually plugs into the outlet. So, you know, those are things that we have to deal with, but honestly, it doesn't affect what we need here. All we really need is a good sort of front section of this where it plugs in near the wall, and then this little transition, and that's going to give us all the detail that we need to build the shelf. So if you want to follow along, go ahead and download the data set from the description of the video. Again, it has 2 mesh bodies in, and we're going to get started on this process. Now, a quick aside here, if you do want to go about it with the traditional method of creating sketches and lofting and building surfaces in that way, you certainly can do that. It is a much longer process to do, and especially when you have complex shapes like the earbud case. So what you need to do in those cases is you'll need to use the mesh tools and create a mesh section sketch, which we covered in the reverse engineering series. And then you'll need to edit that sketch, which will have that mesh section in it. And you can use the sketch tools to try to auto fit a line, an arc, a spline to it. So that process, again, is quite a bit longer than it is with forms. So what we're going to do is we're going to hop in and create a form, and we're going to use this as the basis for our design. Now, there are a couple challenges associated with this. For right now, I don't need to see the charging case. What we're going to do at the end of this is we're going to thicken the form, and then we're going to manipulate the outside of the form. So this piece is actually not a consistent wall thickness when it gets to the shelf. It sort of bumps itself up, which is perfectly fine. If you're 3D printing it, you can print it with no infill, so completely solid, or you can have it do infill at a certain point. I would like to keep the wall thickness consistent. So in my case, I just printed it full instead of worrying about it having thin sections and maybe breaking or something. So the way that I start forms on meshes generally would be to use the face tool with object snap. Now in this case, I'm going to start by creating a single face on the top, clicking at sort of the extents where we see the light or the shadowing change. And then I'm going to carry this up to the next section. Again, snapping to those endpoints. It's hard to see, but the little dot on the screen is black, but it'll turn blue when you find an endpoint. So once we find that endpoint, and I'll try to zoom in so we can maybe see this a little bit better, the dot doesn't get any bigger, unfortunately. And just sort of fill out this space and come back, and then we're going to say okay. Now at this point, I am going to change this to box display, which is Alt and 1 on the keyboard, or utilities and display mode. Now I think it's important that we remember whenever we're working in forms, what we want to do is we want to keep the shape of it and the amount of detail as low as possible for as long as possible. So I'm not going to add extra edges to completely match the shape of it just yet. We're going to build out essentially everywhere that the curvature starts and ends, and then we'll go back and fill in the gaps later. So before I get any further, what I'm going to do is I'm going to double click this edge, insert a new edge, which will be right in the middle, and then add symmetry. So I'm going to add this internal symmetry. It's automatically going to pull everything back together. Now, one issue that we have with working on meshes or scan data is that the origin or the coordinate system is oftentimes not perfectly where we want it. So we can see here the little bumps where the actual plugs are. This right here is not completely centered. It's not in the middle. It just automatically uses the origin or the default origin planes to add that symmetry. So what we need to do is we need to put this in the right place. Now, at this stage in the game, it's a little bit more difficult than later on when we start to wrap around the sides. So you have to decide when it's a good time to do that. For us, what I'm going to do is I'm going to start by moving this edge, and I'm going to just pull it down. I'm going to worry about things being aligned later. What I mean by aligned, like for example, this edge being in the right place, I just want to start by getting the rough curvature down. So I'm going to pull this one out. And the thing that I'm looking for here, which might be a little bit difficult to see, is where these shading or shadow lines are. Now we obviously can see that the plug sort of bulges out in the middle, and that's kind of what I'm trying to replicate here. Now once I have that, I'm going to double click this edge. I'm going to rotate around to bottom view in this case. I'm going to hold down Alt, which is our extrude option, and I want to go to the end of the fillet. So if you think about this thing as just an extruded rectangle and you add a fillet, we're trying to get our edges at the start and the end of those fillets. This is going to help us later on when we go to try to match the underlying shape. Now, because the shape of this, the fillet ends up being, or the rounded corner ends up being larger on this back portion, this means that we also need to adjust the location of that edge. Now at this stage, because I've started extruding, moving things around, I'm not going to move in plane. I want to move vertically and just kind of make sure that I'm moving things in relation to the orientation of it at this stage. It's not critical, but it will help downstream. And once I've moved that, I'm going to use Alt again and extrude down. Again, looking at the location of those, the surrounding geometry and sort of the shading lines. And then we'll do this again from the front. Well, in this case, it's the bottom view because of the orientation. I'm going to pull this around in plane, rotate this around. And again, from this view, I'm going to just move it in the X direction. And this edge here, we're going to move in X, and then we will extrude it again. So Alt, extrude. And now I'm going to move the pivot point to the front, and we're going to scale this so that it's 0. Now, what we're doing here is essentially we're making that a straight line. So with this design, there's no need for us to completely wrap around the charging plug. It's going to give us a little bit more flexibility if our dimensions are a little bit off, or if the printer ends up printing a little bit small, or the part shrinks a little bit, then we have a little bit more room for error. And we can make this thing a little bit bigger or a little bit smaller and still have it fit, and it's really going to be helpful. So now we've got the rough shape. We want to look at the orientation of these edges to try to make sure that we are actually symmetric or in the middle. Now, what we can see here, let's go ahead and rotate it around. This side right here is a little bit inside the mesh, and this side is outside the mesh, which tells me that the entire part is just slightly off center. So I'm going to select the whole body, use move, and I want to move it slightly to the right. Now you can see that it's jumping a whole millimeter, which is more than we need. So I'm probably going to manually enter 0.5. Looks to be a bit too much. I'm going to go down to 0.25, and that looks to be enough. Now, whenever you select an entire body and move it, the selection filter automatically changes to body, which is Alt and G. We want to go back to the All option, which allows us to select the body, face, edge, or vertice. So what we're going to be doing now is trying to add that extra level of detail. Now, there's one step in this process that you can use if you want to, and that's the modify and pull command. Now, if we're trying to perfectly replicate a scanned surface, then pull will let us take our surface or control points. The control points are on the box display, surface are on the smooth display, and this will let us take those down to our reference mesh. I don't actually think that it's needed in this case. Whenever we're looking at a freeform design and we kind of see the form body and we see the underlying scan, that's telling us that we have pretty good alignment between the faces. Now, this part is injection molded. There's a parting line on the side. So I can tell that the side is not actually going to be flat. It is actually going to have a small amount of taper to it. But the tops and the bottoms are likely flat, just based on the orientation of the parting line that we see on the side of this part. So having that in mind, or just kind of knowing that, I'm pretty sure that the top and the bottom are going to be relatively flat, and the side is going to have that little bit of parting line, which we're not going to worry about. It's probably less than a degree. I'm sure Samsung can afford some pretty high-end molds for this stuff. So we're just going to move forward with doing this manually. Now, I will say that once we move things, notice that the bottom is not matching the shape. So this face, and this face are off by a little bit. So we want to move those, and we want to just sort of pull that up. And you can see that it's trying to go a whole millimeter, which is too much. So if we say 0.5, it looks like it gets us pretty close. Could go a little bit more. You can see this one is further away than this one. So I'm going to try moving this up another 0.5. It looks pretty close. I'm going to move this one up 0.25. And once again, what I'm looking for is that sort of marbleization here. So it's a little bit too far, but it's pretty close. Now, again, we can use pull. I'm going to do minus 0.1 here. We can use pull, and that tool will work. So for example, if we do pull and we say our control points, I could say this point and this point down to the mesh. The problem that we have with a design like this is once we start pulling these vertices or faces down to the mesh, then it starts to become harder for us to control. It's going to mess up corners, and really all we need is a couple of faces to reference this. Now, we know that the top and the bottoms are going to be flat. We're going to design it like that. So really all we need is to hit this corner here, and that'll be enough to hold this thing in place. So it all comes down to how much effort you want to put in and how accurate it needs to be. And not everything needs to be accurate, especially when we're going to be 3D printing and there's going to be some tolerance and some variation there. I don't need to spend hours and hours to get this thing perfect. So at this stage, now that it's relatively close, when we look at it in smooth display, which again is Alt and 3, that is pretty far off. Now I'm going to do a quick change here. I'm going to use my appearances. I'm going to say A and drag this onto the mesh. And then I'm going to make my form body red. I know those are kind of horrible colors together here, but this might help us at least see the variation. We can make it blue instead, maybe. We can see where the mesh is high and where it's low. We can see it poking through on the sides. And if we hide the mesh, we just don't have the corner transitions. So we're going to begin by trying to match these corner transitions here and here. And then we're going to worry about these ones on the side. So in order to do this, there's also one more thing that we need to understand about forms. The box display and the smooth display are not always in the same location. There are tools in the utilities such as make uniform, and what they end up doing in some cases is they will adjust the smooth display to get a little bit closer to a uniform layout. So that does have an effect on curvature sometimes. In this case, what we actually want to do, because we know where that control edge is, and this display here, I'm using Alt and 2, which is this middle display. It shows the control frame, but it also will give us the smooth display underneath. It helps us understand what's going on. I don't usually model with this. I usually model in box display and just jump back and forth, but it might help visually as you're learning. So what we're going to do is we need to either insert additional edges, which when we do this and we use modify insert edge, what we're actually doing, and we can see it here on the screen, is we're putting an edge in simple mode, which means that the edge here and the edge here are going to be perfectly in line. Now, in general, that's bad for curvature in these forms. We don't want that. So you can use the exact insertion method, which will keep the shape exactly the same and put the edge usually right in the middle. Again, not a great option for us. So if we end up using insert edge, which is possible, then we need to manually adjust where it is. Now, the tricky thing here, our design wraps around 4 different sides of this plug, which means we're going to have to do scaling instead of moving, or things are going to get pretty messy. So instead of doing that, I'm going to be using the bevel tool. Now, the bevel tool is one that is actually pretty helpful for this, as long as you only use one insert segment. Now, the reason for that is because bevel is going to take the selected edge, and it is going to essentially get rid of that edge and then add an edge on either side of it. So even though we're adding one segment, what that ends up doing is it gets rid of the selected edge and then it helps us start to gradually create that transition. Now, the reason I said as long as you use one segment is because if you had two, then we start getting that same scenario where we have these flats in between. Now, if you're trying to create flat geometry, that might be okay. But if we're trying to create a nice transition, almost like a fillet, then it's problematic. So what I'm going to do is I'm going to insert this at 0.05. And what that means is it's 5% of the distance between the surrounding edges. So in the case of the selected edge, we're much closer to that extra transition on the left side than we are on the right side. So it's going to go further away to the right and a little bit closer to the left. But we're going to say okay, and we can see instantly how it pulls that up for us. Now, if we bring back our mesh, we can see how close we are here. And we can see it's still underneath a little bit, but that means that what we can do is we can take these two edges. I'm going to use modify, and I'm going to pull them forward a little bit. Now, pulling them forward means that we're essentially moving it a little bit closer. Now, there is another trick that we can do here to help us because we're slightly inside of the mesh. We can right-click on the mesh, go to opacity control, and actually make it somewhat see-through. So this will give us a better understanding as to where our form is in relation to the mesh. We can see it's coming through just on the top. And if we rotate this around, that corner doesn't look too bad. If I use Alt and 3, really all I'm looking for right now is that it's close in the middle. Because I haven't done anything with these corners yet. I'm not worried about those yet. I want to make sure that it's close in the middle. So what I want to do is I want to find that edge. So this edge right here, and I want to see where that is in relation to my mesh. So it's a little bit low, but it's actually pretty close. At the end of this, we're going to scale it up just slightly. So that's probably okay for now. We can take the whole thing and scale the whole thing out uniformly. So as long as we're equidistant on all sides, it's perfectly fine. Now, if you want this to be perfect, you can always try to select everything and use pull, and again, pull it out to the mesh. I don't think it's worth it in this case, but it is something that you can do. So the next thing that we want to do is repeat that process using Bevel. And I'm going to use the same settings. I'm going to say okay, and then take a look at this from the side. So what we end up having is we're kind of missing the point here, but down here, it actually looks pretty good. So what I want to do is I want to take those edges, and what I mean those edges, these two right here, because I like that transition, and I want to move them back. So I'm just going to pull them back, and you can see now it looks pretty good. Again, we're just slightly inside, but overall the shape looks pretty good. Once again, the intent here, we're not reverse engineering this part, we're just getting it close. Now, I do get comments from time to time on my videos that say they're just too long, they take a bit too much time. And I do understand that. The intent of this channel was never really meant to be those quick videos, those quick tips with just the highlight points. I do that work a lot. I make videos for Autodesk, and those are more to the point on certain tools and features. This was really intended to look more at the thought process while we're doing these things. So if that isn't your cup of tea and you've made it 20 some minutes into this video, well, I think most of my videos are going to be like that. So that's just the nature of it. Thought I'd mention it. All right, so again, we're pretty close. The next thing that we're going to do is we're going to try to get these corners good. Now, this is actually going to be slightly different. And the reason I say it's slightly different is because we can slide these edges to get close. But remember, we want the top and the bottom to basically be flat. So in order to keep those flat and also to get into this corner, there are a couple ways that we can do this. We can try to slide edges, and we'll take a look at how that looks. We can try to pull this edge over, but you see what's actually happening is the curvature underneath, and we're going to undo this. The curvature underneath is going to make the top of it more rounded. So instead of doing that, I'm going to do Control-Z and undo. But instead of doing that, we can use that same bevel trick. And what bevel is going to do is it's going to insert those two edges, which will be the start and the end of that transition. And once we have the start and the end of it, then we can say, delete this one, and then insert an edge right in the middle. So I'm going to go minus 0.5. And this gets us a little bit closer. Even though in box display that's flat, this gets a little bit closer. And what we want to do now is we want to take this and move it out slightly because we don't want that flat in between there. We don't want these two edges to be straight, otherwise we don't need them to be there. So if we bring this back and we take a look at smooth display, you can see that we've started to create that transition a little bit more. Now, again, this is not perfect, it's not one-to-one, but this is the process of how you try to get these shapes. Now, at this stage, it's pretty close. At the bottom, instead of using the bevel, we can just also insert the edge like we did, and then we can manually move that around. Again, I want to make sure that it's not flat, so you can see here the angle between these two lines are collinear or parallel. I want to make sure that they have some angle between them, so that way we're controlling that transition. Now you can see here, we can kind of play around with it and move things around and get it pretty close. You always do have other tools in your bag of tricks, things like flatten, things like smooth, and you can use these. But I find that taking the time to build out the designs from the very ground up with as the least amount of faces, edges, and vertices as possible is the best way to go about it. Now, I will take a look at using pull just so we can see what that looks like. I'm going to go to select everything. We want to make sure our mesh is visible, and we're going to go to the pull tool. Now, this will allow us to take vertices and pull them out to the closest reference in the mesh. Now, I'm going to talk about why I don't like this tool in this case in just a second, but let's say okay, and let's look at the results. So the results look a bit better in terms of matching the outside shape, but if we hide the mesh, what actually ends up happening is you can see, because this vertice and this vertice had to touch the mesh, we now have this up and down that happens in the middle, and you can see these corners are affected as well. So it has a negative effect on the overall shape. Now, the way that I use pull is if I'm trying to replicate part of a car fender or a big complex shape like that, then pull makes sense. But usually you only use it on one edge or one row of vertices, potentially two rows of vertices for your designs. So I'm going to do Control Z to undo. And really all I want to do is start to manually manipulate these things. Now, I know I said that that was not the best option, but manually manipulating these is certainly going to help us get the process down. Before we do that, let's go ahead, double click this edge, and we're going to insert an edge. I'm going to say both sides, even though it doesn't matter. Because we have symmetry, it's going to automatically add it to both. But I'm going to say both sides. And the reason that I want to do this is because this is getting us closer to that flat. Now, if we actually take a look at it, it's not perfectly flat. It actually will bow down and back up because those are actually perfectly in line edges. So we don't necessarily want to see that. What we want is we want this center one to be a little bit higher. So I'm going to just hit the vertical direction and just give it a small amount, 0.05. And then I'm going to take this edge, and that is always in the way. I'm going to take that, and I'm going to go up a small amount, 0.01. And the reason for that is because this edge at the top and this edge originally were in line. And because it's a start and an end, that's perfectly fine. It was just one edge. But when we divided it in the middle, now those 3 points across that edge were the same, or 5 if we include symmetry. So moving them all up just a little bit helps get a very gradual change to it. Now, if you are looking to perfectly replicate this part and it does have a perfectly flat face, you're not going to get that with the forms. It's just not going to be a good solution. So in that case, if you're trying to perfectly match it, I would go to the sketches. A couple of other things that we want to look at and identify here, and I'm actually going to change the color of this just to make the edge display a little bit easier. Whenever we have a transition or a corner like this, what we want to see is that these are pointing toward the artificial center point. So if we think about this in terms of a sketch, I'm going to go ahead and just create an arc. So if we look at an arc, this is its center point here. So if we have two arcs, I'm just going to go ahead and offset this in here. Those two arcs have the same center point. And if we draw lines from here and here, those lines are perpendicular to the curvature at that point in the arc. If we do the same thing over here from the midpoint, or if we start dividing it up here, essentially what we want is we want all of these edges to end up at that same central point. Now I'm going to do undo because I don't need this sketch, but essentially what we want is the direction of these edges here, we want that to be pointing at the center of the radius of our arc. Right now they're not, so you can see these ones are sort of not in the correct position. So I'm going to start pulling these out and potentially rotating them. Now you have to be careful when you start rotating edges, because what ends up happening is you're rotating it, but you're keeping the length the same of that edge. And in reality, if you rotate an edge on an arc like that, the length, in this case, the length is going to have to change. So it's a little tricky, but again, what we want to do is we want to sort of rotate these. Might be good to scale them a little bit and just kind of play around. So again, I want this to point to where I think the center of that radius is. So if we hide the mesh and we look at this in just smooth display, again, we're trying to get that corner just to be a little bit more realistic. The same thing down here. When we take a look at this, you can see the direction that those edges are going. What I want is I want those to point to the center, and you can see it's changing the width here. So I'm going to scale it down just a little bit. I still want that width to be consistent. This one's going to be a little bit harder to select. So I need to maybe just double click the entire edge, rotate it slightly, scale it down a little bit, and grab this one here. Maybe pull it up and rotate it and scale it. Now, as we're looking at it from this view, remember that these faces, that's where the transition is happening. And the reason I'm so concerned with the angle is because we want the transition, or this fillet radius, to carry across the design pretty well. So I want to manipulate all the edges together, all the faces together, and not get in the habit of just manually moving points, because then we're going to start affecting the distance between these vertices or the length of these edges, and that's not really what we want. So looking okay, looking pretty good. And we can make some small adjustments here. I generally say don't work in smooth display, but there are times when working in smooth display makes sense. Like now, moving this around until I'm seeing that sort of marbleization. I think that I want to insert another edge on the side because I know that it's flat. I'm going to go ahead and do a single. This is going to be positive 0.5. And again, we want to make some adjustments based on that. Anytime we insert an edge, it is going to have an effect on the curvature. So make sure that you do just double check everything. So as I rotate this around, what I'm looking to see at this point is the yellow of the form body and the mesh are going to be pretty close when we're in smooth display. So when I'm in smooth display, I'm kind of seeing that marbleization. As I rotate this around, we get a little bit more form, a little bit less mesh. The corners are still a bit tight. They probably need some more adjustment. Looks okay right here at the front, which means that I'm going to select this edge, control double click here, and move this out in plane, and we can get a sort of a live view of what's happening there. So once again, everything looks pretty close, pretty happy with that. So what I want to do now is I want to take the entire thing and I'm going to scale it out. And the reason I'm doing this is because I know that when I 3D print this, it's going to be just a little bit smaller than what we see here. So any of those overlaps where our form is actually inside of the mesh, it's just going to be a worse problem for us. It's not going to fit. So we're going to make it a little bit bigger. 1 is 100%. 1.05 makes it go 5% bigger, which is probably too much. I'm going to just do 1.01. And that makes it 1% bigger. And then you can kind of see we're still seeing that in the corners, a little bit more on one side than the other. But overall, that looks pretty good. You can always print this and scale it in your slicer as well. If you're using Fusion 360 as the slicer, or if you're using whatever is with your printer, then you can scale it up there as well if you find that it's printing small. Oftentimes what I do, if I have things that need to fit well, I'll print a very small section of it. So for example, I might slice off the first couple millimeters of the end, just print that, and see how well it fits, and that kind of gives me an indication if I need to make any drastic changes. But a key takeaway here so far is that when we're working in forms, we're going to start with a low level of detail. We're going to start with a very rough approximation of the shapes in box display. Then we're going to slowly and gradually add more detail as it's needed. So everything so far looks pretty good. I'm happy with the shape. I'm happy with the results. And again, you kind of have to think where you need it to hit. As long as it's hitting this edge here, I don't need it to perfectly match. And we are going to leave a small amount of a gap in the front. So if it does sit back a little bit further, it's not a big deal. So now the big question is, what do we do with this? This is just a surface. If I click Finish Form, I can thicken it in the sort of design space using solid or surface tools. And then we can continue to add more details. If you're comfortable with that, then you can do that. You can continue to work with it there. What I'm going to do here is I'm going to work with a thickened form, which gives us the option to manipulate the inside and the outside individually. So right now, what we have is the inside shape of our form. Before I thicken it, what I want to think about is if I need to subdivide it at all. Now, subdivision is great if you need more detail in certain areas or over the entire part. However, if you're not happy with the shape, it complicates things downstream. It makes it harder for us to edit. So I'm happy with the way that this looks. I know that it's going to be okay, and I can scale it up if I need to. So I'm going to go to Modify and Subdivide, select the entire thing, but I want to use the exact simplification. Now the reason for that is exact will maintain the shape that we have and just divide each face up however many times we specify. So under Specify, I can start to increase the length or the width faces. Now I actually don't need any more in the length necessarily, but I do want to add more in the width. Now when we do this on a design like this, the smaller faces are going to get a lot more divisions. So these areas where we have the transitions, you can see those are getting divided as well. What we can do is instead of selecting the entire body, we can select just the faces that we want. So I'm going to hold down Control and select those faces. So this will allow us to divide just that area, again using exact simplification, but now we can use that to sort of build out the rest of the platform. So I'm going to carry that over to the corners as well. Remember, because it's symmetry, I only really need to select half of it, but I wanted to go ahead and select a bit more. So I think that that's okay. If I want to build off of the geometry down here, I might want to divide these up as well. But again, I'm looking at just the top of it. I'm not looking at the entire thing. So if I do need to make changes, it's not necessarily that hard. So we're going to do 2 in the length direction, 5 in the width, just selecting those top faces and making sure that those are the ones that we're dividing up. Now that we have that, Modify and Thicken, we're going to select the body, and we're going to use the thicken type of sharp and the direction normal. You can pick how thick you want this thing to be. In this case, if we do -1, it's going to give us 1 millimeter in that negative direction. You have to think about your printer and how thick you actually need your parts to be. I'm going to make it a bit thicker, which is probably overkill for this, but I'm going to do 2 millimeters. And actually, let's go a little bit smaller than that. Let's go 1.5. Some other things to consider as well when you're thinking about these thicknesses is the printer nozzle and settings on your printer, how wide you can actually print. If we do 1.5 millimeters and we end up needing like multiple traces to go in that thickness, then are those going to be actually adhered together, or are they going to delaminate or separate? These are things that you kind of have to play around with on your own printer. So now that we have this, the next step in the process is to start building the pod on top. I don't really need to see the plug anymore, but now we want to add some geometry that will allow us to sort of give this a shelf, a cradle to sit on. How much you add really depends on what you're doing. Obviously, we only really need 3 or 4 points of contact. In this first version, I created an actual just shelf there to make it a little bit more robust. It doesn't fit great. I'm going to do a little bit better job this time. But again, we could just do 3 or 4 points in the corners, and that could be perfectly fine, or we could try to match the shape as well. So where this gets a little bit tricky is now we have a lot to manipulate. So this is where it starts to sort of come into play. Now, one thing that we can do is, I'm going to hide this for now. One thing we can do is we can select a face, hold down Shift and hit the up arrow, and that will allow us to start expanding our selection. So let's say I select this face and maybe this face and start hitting Shift and up. It'll start to grow that selection and make it quite a bit easier. If you're inside of Edit Form, there are selection options to sort of quickly and easily do that. We can also change our selection type to paint. So if I just start dragging this over, I can start painting. The problem with that is by default, it's going to select through. And then you also have to worry about selecting edges and vertices. So if you use paint selection, you want to make sure that you turn off select through. And you also want to prioritize the option to just select faces. So we don't want to select vertices, and we don't necessarily want to select edges. Now, the trick about this is that actually comes from this selection option here. So again, we have to sort of turn that off and toggle it. It all just kind of depends on how you like to work. I like using the Shift and up method if it can get me the results I need. But the paint method, especially when you turn off select through, can be pretty valuable as well. So it's pretty quick for us just holding down the left mouse button and working our way around. And once we have all of that, what we can do is we can start to pull this up. Remember, we are only modifying the outside. So the inside is staying exactly like it is because we had select through turned off, but we're just modifying the outside, which means I can start to do things like flatten these and move these together. And if we bring back the mesh, we can start to see where we're going to begin hitting that. So you can see here, we're starting to hit that. We need to bring these faces out and potentially some of these up. But so far, it gives us something to work towards. So what I'm going to do is I'm going to change my selection back to all. And I want to take a couple of these edges, and just from the side, I'm going to pull them out and up. Keep in mind that this is a sharp corner. We're probably going to need to fill that after the fact. But you can see that we're starting to sort of cradle that. We will need to make adjustments in here, potentially move some edges around. But once again, we can just make selections knowing that we're working directly on the outside and we're not affecting the inside at all. I can pull that down and start to make that little pocket. And one thing that you can also do is you can create a section analysis. And what we're going to do is we're going to cut through here, and that'll actually cut through the mesh as well as the form body. And as long as that section is on, this can help us see inside of here to decide if we need potentially more edges or more control here. Now, with Fusion Forms, we do have the option to create what are called T-points. And T-points allow us to add edges that terminate in the middle of a design. I'm going to turn off section analysis for now and repeat the insert point here. But what this allows us to do is potentially take these two edges and just move them down to sort of create that pocket a little bit better. So again, the goal here is to try to match the shape, and using these tools like the section analysis and adding those T-points can help us. Keep in mind that we generally want to avoid manipulating a T-point at an edge here. We still want that edge to be straight with a T-point. It's kind of against the other rules that I say where we don't want those edges straight. But in this case, it's perfectly fine, and it's actually better. As soon as we start pulling that down, it causes problems. If you do need to manipulate that, then I suggest doing another insert point. And then now we can pull this, this vertex down a little bit. So bring back the mesh and start to pull that one down. So again, the goal here is for us to match the shape, not necessarily perfectly, but fairly well. So we can start to select these edges, keeping in mind that we have symmetry. So as we begin manipulating this, as long as we are selecting up to that symmetry line, then we will be able to sort of keep everything in check. So again, we're going to pull that up a little bit and toggle on and off the visibility and symmetry whenever we need to. I'm going to pull that one up just slightly. Remember, this doesn't need to be perfect either. We're talking about an ear pod sitting on a 3D printed part. But this is the basic way that we can start to build out that shape. And over here, what I'm going to do is I'm going to take some of these internal edges and just pull them up. And again, just give it something to rest on. You can pull them out as far as you want. We can always add more edges if we need more detail, but just rotate things around. Get a good idea of where it's sitting, where it's fitting. Again, we just have a couple points of contact. And then at the front, what I'm going to do is I'm going to toggle off the section analysis, and I'm going to take a couple of these faces and pull them up. So again, we can give a point of contact there. So now we've got 4 points of contact. This cradles it pretty well, keeps it from falling off the side. And then this is sort of just like a little bump, a bump stop there. We can always do more. So for example, let's go ahead and grab a couple of these faces and begin pulling that up. You can see that it's causing this little wrinkle here, and that's because of the edges underneath. So when we're talking about the edges underneath, what we're doing is we're talking about the box display. The edges are actually going to be closer than they are in smooth display. So I'm going to do Control Z. I'm going to put that back. But now what I want to do, notice that there's a slight overlap. There's like an extra edge here. So if I pull this back, you can see it starts to expose that edge. So what I'm going to do is I'm going to select these faces. I'm going to pull them forward and see that we've got this sort of overlap here. Whenever we have something like that, because this is again on the outside, what we can do is I can double click that entire edge and just delete it, and that'll alleviate that sort of overlap problem. I'm actually going to take this one and delete it as well. We don't need that much in that area. This face right here could potentially be a problem the way that it's generated. It looks like it's okay, but those areas, when you have a single face that's changing like that, those can potentially cause problems downstream. But now that we've got that sort of taken care of, I'm going to go ahead and bring this edge up. And here's where we can start to see that might potentially be a problem. Go ahead and bring that down. And again, it looks okay. You can obviously spend as little or as much time as you want here. I'm going to start deleting some of these extra edges that we don't need, simply because we only really care that the inside shape matches the plug. The outside shape doesn't need to follow or flow, but you want to be careful that you're not deleting an inside edge like this. So you can see that edge goes all the way through, whereas some of those other ones, because we subdivided just the top, they didn't go all the way through. So if we want to clear these, what we need to do is hold down Control and double click, and then we can delete just the top section, leaving that T-point there. So if we look at this in box display, it sort of simplifies things a little bit. If we bring back the mesh and we go back to our smooth display, you can see that we're sort of bumped up a little too high, but again, it's not really a big deal. I think that's okay. That will all print pretty well, and I think that's okay. Anytime you see a dark edge like this, that is a crease, which means that we can add a fillet to it once we convert it to a solid. So I'm okay with that design so far. What I'm going to do is finish the form. I'm going to change this back to window select just because I don't want to forget that it was on, and turn on select through. You can see that the outside shape, even though it's mustard color, it looks pretty smooth and pretty good. What I want to do now is I want to cut the opening for that USB. So we're going to do a sketch on the side and rotate that. And it doesn't need to be super precise. I'm just going to make a rectangle that's big enough so that a USB cable can fit there. Notice I didn't even give it dimensions. And then we're just going to extrude that out. I'm going to go all in both directions. Now, when you do all, you will need to make sure that it is symmetric. I do want to cut out from both sides, just in case this thing gets flipped over and want the plug on the other side. And then now we're going to use fillet, which is F on the keyboard or right up here, and then just select all those edges. I want to make sure that everything is nice and round. Same thing down here. I want to make sure that these edges are round. These edges here. Do remember that since we are 3D printing this, the edges that sit on the build platform, which are these front ones, you might potentially want to leave square if it's going to have a problem printing those fillets there, or maybe add a chamfer instead. And we can just see what 1 millimeter looks like. It's enough to take sort of the edge off. Say okay. So far, so good. Everything looks okay. That front edge looks flat. It bulges out. It holds the ear pod on top. Last thing I want to take care of is this knife edge right here. So when we add a fillet to something like that, remember we have 1.5 millimeter wall thickness. If I actually add a fairly large fillet to that, what ends up happening is it takes away a good bit of that design, which might be okay. It might be perfectly fine. But notice it's adding fillets everywhere else. So what you might want to do in a case like this is go back into the form and potentially insert another edge. So what we're going to do is we're going to go to insert edge. I'm going to say minus 0.5. And then we can take these inside edges. Remember, we're not worried about the inside shape. That's what we have to match the underlying plug, and just pull these out so that we don't have such a quite drastic edge. We still have an edge there, but it's not quite as bad, and that'll give us a nice smooth result. And if we finish form, nothing else should be affected. Everything should still be fine, and we can sort of keep that shape. So I'm pretty happy with that. I think that's a pretty good result. I want to save this, and then I want to 3D print it. So 3D printing it, that is, again, it's going to come down to if you want to use your own slicer or the Fusion slicer. I'm going to go ahead and call this earbud shelf. I'm going to turn it into a component. Fusion likes components better when we're using additive manufacturing. I'm going to go to the manufacturer workspace and create a new setup in additive. Now for me, I already have the Ender 7 in here. It was an option, it was a download. I was able to get that. I'm going to select that machine. The operation type is going to be additive. Arrangement is on, which means it's going to go ahead and move that over. The two meshes I certainly don't want to print. So for the model, I'm going to just select the component underneath the manufacturer model. So expand this and grab that component, which will eliminate those two meshes. And for post-process, the program name, I'm going to do CE7 because I'm using an Ender 7, and I'm going to do earbud shelf. We then need to pick a setting. So I have a couple of sort of pre-saved defaults for materials. This is something that you will have to spend a little bit of time on when you're using Fusion 360 as opposed to, let's say, in this case, the Creality slicer. The Creality comes pretty well set up once you select your machine. The Fusion one does not. Now the machine is in there, but all of the settings for the speeds and the temperatures and all those kinds of things, that all comes down to what you're actually doing for your print settings. And there are some defaults there depending on your machine. The defaults might work okay. I'm going to go ahead and allow it to arrange that to put it in the middle. And then I want to take a look at my settings. As I mentioned, I already changed this, but I'm going to right click and edit and then just take a look at a couple of the settings. So we have some general settings here. So these are things like the fillet diameter, the print bed temperature. So for me, that's going to be 65 degrees. We have layer heights and travel speed. So these layers, it's essentially going to be your resolution. So if you're doing a low resolution print, you're going to have to manually pick those numbers. And one thing that Fusion 360 does that most of the other slicers don't do is it allows you to generate a G2, G3 movement, which, because it's actually G code that's controlling these machines, the G2, G3 are true arc movements. Because we are dealing with solid geometry, it is able to convert to G2, G3 moves, where a lot of times the slicers that are just dealing with mesh data aren't. So inside of here, under the body presets, you can create multiple body presets. So for example, if we were using the Fusion 360 print for multiple bodies and we wanted some to have no infill, some to have 50% infill, for example, you can dictate all that by modifying these print settings. So in here, the extrusion is going to be, in this case, 0.4 is going to be the default. It's what I'm going to use. The flow values, the temperature for me is going to be 220, standby temperature. The retract length and retract speed, this is going to vary again based on machines. Now, my machine has the sort of the Bowden tube setup where it's actually quite a bit far away from the extruder. And I worked a lot with some people at Autodesk and some people very helpful on the Discord for this channel to kind of dial this in. Originally, I think the default is something like 0.5, which is fine if all your extruder stuff and the drive for that is at the head, but mine is pretty far away. So playing around with that, looking at the Creality settings in the Creality slicer, arrived at the retraction speed and length here. Values for things like shell, if you want to have infill, then you want to make sure that you define this. So for me, looking at this, we need to think about whether or not it's going to be shelled or whether or not we're going to do infill. I'm going to do 100%. I want it to be completely solid. Print bed adhesion, I do want to use a brim, and I'm going to add a couple more brim loops just to make sure. We're not doing support, so I'm not going to have any support on this. The speeds, again, it comes down to your machine. I'm going to use these speeds. The Creality under 7 will go up to 250 millimeters per second. Now, I have found that certain things work better than others with these settings, but I'm just going to leave all these. Leave all these settings off, nozzle wipes off, tessellation, these are all default. I'm going to say OK. And then from here, what we need to do is select the additive toolpath and generate it, which is Control G. And once we generate it, we'll be able to preview it. Make sure that we are getting the brim. If you are using supports, then you can generate the supports here. There are some manual options. But once we have that, we can go to Actions and we can simulate. And this will allow us to play through each layer. So here's the brim support, for example. And then it starts building the part. I'm going to speed this up. Gives you a little key on the bottom, kind of tells you what's going on for this. You can see it looks like it actually is doing a gyroid infill. So, but again, that's not necessarily a bad thing for this part. I can go back and tweak the settings if I want to. Once I'm happy with this and assuming everything does print okay, if you haven't used manufacturing in Fusion before, you are essentially generating an NC program. Now, if you go to setup, there's no NC program here, But what we actually are going to do is we're going to post-process this. If you're using it for CNC mill, for example, you would create an NC program and then post-process that. Once we do post-process here, it automatically creates that NC program for us. I need to go ahead and insert the jump drive so it has a place to put that. And then I can just make sure that it is finding that G drive just fine. So let's just double check. It's calling F this time. So we'll make sure that it goes there. It is going to, let's see, it is going to be using the Ender 7 Core XY, which is the post processor. It converts everything here into code that can read. The machine doesn't have auto leveling. There are some general settings that we can toggle on and off here. Everything looks good, so I'm going to say post. It's going to put that into my jump drive. We'll just take a quick look to make sure. And earbud shelf, CE7 earbud shelf there. So now I can eject that and take it over to the printer.
Well, here we are at the very end. The part is printed, it has been used, and everything works pretty well. So a couple of confessions. First, this is a couple days later. I ended up filming this the same day, but I had some audio issues, and the audio that came through on the camera was just way too echoey. I didn't want to use it, and for whatever reason just had mic issues. So I ended up filming this. This is about 2 days later. The second thing is I ended up not using the Fusion Slicer. Now, there wasn't really a problem with the Fusion Slicer. The problem is that this part is 1.5 millimeters thin. And when I printed it with just a brim, it wasn't quite enough. So what ended up happening is it got partway through and it just got caught up on the nozzle or something and popped off. So I ended up rerunning it, same exact settings with the Creality Slicer, same exact thing happened. It just wasn't enough adhesion to hold it to the build platform with just the brim. So what I ended up doing was running it with Raft, and I ended up just doing it through the Creality Slicer because I already had the part open in it. It was just an easy change to make. But again, that's no fault of the slicer in Fusion. It just happened to be the case that I had the Creality one open, but printing it with Fusion and with Creality gave me the same exact results. Got about halfway through and just wasn't able to stay adhered to the build platform. Because this is a couple days later, I am happy to report that this part has been in use and it does work well. So 1.5 millimeters was a good choice. This is about the right size. The original blue one was 2 millimeters and it was a bit too much. It does fit the plug really well, so it slides right on. And again, we left a little bit of a gap and it can't go anywhere because it'll be plugged into the wall, so there's really nowhere for it to go. If you wanted to make any future adjustments or changes, what I would probably say is that on the back here where the shelf is, we could wrap just around the back of the plug and maybe snap on. Not really needed, but if you wanted a little bit more of a secure fit, that would work. It actually does fit really well, so scaling it up that 1% was just enough to get this to fit perfectly. And the ear pods fit really well on there. So it has a nice cradle on the backside and it has that point of contact on the front. So it has it on the back, the two sides here, and that sort of locates it, and then that front piece sort of holds it. So as I said, this has been in use for a few days, and it works pretty well, a little bit better than that first version. Could, of course, do more. We could have a more positive hold on the case. Not really needed. So it kind of just comes down to what your end goal is. Now, I think this part was somewhat difficult to make because it required having a scan of the plug, but that's not necessarily the case. You can do this without a scanner if you want to. So I've done things like this in the past where I basically take the part, put it on a piece of paper, and trace it. Remember, there's a parting line on the side. You know that the top and the bottom are relatively flat, so what you can end up doing is just tracing it and getting it pretty close. Remember, we don't need to perfectly match this. We only need to have it hold on to this section and this section here. And we need to know about how far back that is. So you could do this with some measurements, a piece of grid or graph paper that you can scan in on a photo scanner and get you probably close enough to make this happen. The 3D scanner was a great way to do this because it was set up, the turntable was ready, and I had a pretty quick way to scan this. Would be quite a bit more difficult to reverse engineer this pod. Not necessarily impossible, but it would be a little bit trickier. So what I would say is, if that were the case, if I didn't scan this, what I would probably end up doing is holding it on to the sides a bit more. Instead of worrying about the curvature here, I'd probably just have a couple points of contact to grab onto it. Again, it all comes down to what you end up needing. So with that in mind, and with sort of this part out of the way, it's important to think about what you can do with the tools that you have. So this is a good end use part. It's a good use case for 3D scanning and also 3D printing. Something that doesn't necessarily exist, but it solves a simple problem. And that's just keeping these ear pods from just dangling off of a plug. So with that in mind, if you end up making something like this using the scans, I'd love to see it. If you want to send me an image, you can always send me an email, support@caducator.com. As for this series, this is as far as this one's going to go. But if you have any questions, you can leave a comment below, or again, you can email me. But as always, thanks for watching, and we'll see you in the next one.